All right, Algebra 2, we're going to go ahead and start Unit 9. We're just going to look at the first part of Unit 9.1 today, and then we'll finish off the notes the next time we meet. All right, so a rational number is any number or term that can be written as a fraction, like a over b. A and b, when we just have numbers, they're going to be integers, so they can be positive numbers or negative numbers. And then the only exclusion b, which is in the denominator, cannot be 0. So we never want the denominator to be 0. All right, so what we want to do is go ahead and we're going to review simplifying fractions, and then we can also simplify multiplying and dividing also. All right, so if we have the fraction 35 over 40, we want to simplify that. We can see that 5 goes into both of them. And so we can divide top and bottom by 5. And that just means that we're canceling out the 5s. Okay, because 35 is really 5 times 7, 40 is 5 times 8. And so this really just simplifies down to 7 over 8. Okay, and then we could do B also, 21 over 28. Find a number that goes in the top and bottom, and so that is going to be 7. And so we're really just dividing by 7. All right, so 21 times, 7 times 3 is 21, and 7 times 4 is 28. And so if we divide by 7, we can get 3 over 4. All right, multiplying fractions. There's two ways you can multiply fractions. One way is to just multiply straight across. So we could multiply the numerators together and the denominators together, and then we could just simplify that fraction at the end, just like we did above. Another way that you can do this is to simplify first. So you could cross cancel diagonally or top and bottom first, and then multiply across whatever's left. Okay, so if we see the 12 and the 3 diagonal here on this first question, we can divide by 3. And so 12 divided by 3 is 4, 3 divided by 3 is 1. Nothing goes into 2 and 5, so then this is where we just go ahead and just multiply straight across. All right, so 4 times 2 is 8, and 5 times 1 is 5. And we can see, again, nothing goes into 8 and 5, and so that means that this is simplified all the way. Doing question B, again, if we look top and bottom, 7 over 4, nothing goes into both of those. 15 over 6, now we could simplify 15 over 6 first, and that's just dividing by 3 because 3 goes into both of them. Right, so 15 divided by 3 is going to be 5, and 6 divided by 3 is going to change to 2. And then if we multiply straight across again, 7 times 5 is 35. 4 times 2 is 8. All right, again, we can see nothing goes into 35 and 8, so that means it's simplified all the way. All right, when we're dividing fractions, we can kind of remember this KCF, that's keep the left fraction. We're going to change the division to a multiplication, and then we flip the right side fraction. All right, so keep, and then change from division to multiplication, and then change the right side fraction by flipping it. All right, so we never really divide fractions. It's always changed to a multiplication, and then we're multiplying by the reciprocal, which is flipping the right side fraction. All right, so 2 over 7 divided by 6 over 5 is really 2 over 7 times 5 over 6. All right, so now we've changed it to a multiplication problem. Again, if you want to simplify first diagonally by dividing by 2 first, then you could multiply straight across because it's a multiplication problem. 1 times 5 is 5, 7 times 3 is 21. So 5 over 21 would be the answer. All right, now B looks a little different. It's 6/4 divided by 10/9. So this is called a complex fraction when you have fractions being divided by fractions. Right? And so what we want to always do is find that main fraction bar. And so we can see here's that main fraction bar right here under the 4. And so this is really written as a division problem. So we could write this as 6/4 divided by 10/9. Okay, so that's how you would read that, 6/4 divided by 10/9. So now, since it's a division problem, we would change it to a multiplication. Okay, and we flip the right side fraction, so it's 9/10 now. And then again, if you could simplify diagonally, you can do that. So we could divide by 2 So 6 turns to a 3. 10 divided by 2 is 5. And then we can multiply straight across. So that's going to be 27 over 20. All right, again, 27 over 20 is not going to simplify, so that's our final answer. So again, I just wanted you to see where we're headed with these, and now we're going to be having variables in there, and binomials and trinomials, but this is the basic idea behind simplifying fractions, multiplying, and dividing. All right, so let's go ahead and practice these. So again, when we're multiplying fractions, you can multiply straight across and then simplify at the end, or you can cross cancel first, so it's up to you. So when you have variables with exponents, and there's no binomials in the problem, what I would probably do, like on number 1, is just multiply straight across. It's going to make it a little bit easier if you multiply and then simplify at the end. So 3 times 5 is 15. Now x squared times x cubed, because we're multiplying variables, we would add the exponents. So that's x to the 5th. Then on the bottom, 8 times 4 is 32. And then x times x to the 5th, that's x to the 6. Okay, remember there's a little 1 on that x. So here is where we want to simplify. So I could divide to simplify, let's see, 15 over 32. It doesn't look like anything's going to go into 15 and 32, so that's done. Now, x to the 5th over x to the 6th, since they're the same variable, we're going to subtract exponents. And when we subtract exponents, we always want to bring the smaller exponent to the bigger one to do the subtraction. Okay, so I'm going to bring that 5 down and subtract in the denominator. So when I bring that down, I'm actually bringing the whole x down with it. So my answer is going to have a 15 on top and 32 on the bottom. And then on the bottom, that x to the 6 minus 5 becomes x to the 1st. Okay? And so then that's simplified all the way. So we don't want to leave any exponents that have a negative, so no negative exponents. We want to make sure our coefficients are simplified, the 15 over 32, it is. And so then that's our answer. All right, number 2, again, we have a division just like above, and so we want to keep the left side fraction the way it is. We're going to change to a multiplication and flip the right side fraction. All right, so 10x to the 3rd y7 over 8y4. All right, again, because there's all these variables and exponents, when you start cross-canceling on these kind of problems, things get real messy, and then it's hard to see what's left that you can multiply. So again, with these exponents, I would just multiply straight across and then simplify at the end. All right, so the coefficients, there's a 1 in front of this x, so 1 times 10 gives us 10. Now I can multiply the x's together, so that means I'm adding the exponents. So that's going to be x to the 8th. And then the y times y7 is y to the 8th also. On the bottom, 5 times 8 is 40. And then x, there's no other x's. And then y to the 4th, there's no other y's. Okay. So again, we're going to line up the x's with the x's and the y's with the y's also. All right, so now let's go ahead and simplify. So 10 over 40 I can divide by 10. So that's going to change to 1/4. X to the 8 over x, I'm going to bring this 1 up and subtract. All right, so 8 minus 1 is 7. So x to the 7 on top. Y8 over y4, again, I'm going to bring that 4 up to do the subtraction. So 8 minus 4 is 4. So y to the 4th on top. If you don't want to put the 1 in front on the top, you don't have to have 1 over 4. I just did it just so you can see that I simplified 10/40ths. All right, so then that's the final answer. All right, number 3, again, we have this complex fraction. So let's go ahead and rewrite it as a division problem first. So y to the 3rd over 2 divided by negative 10y over 8x squared. All right, and then we'll change to a multiplication problem. So let's rewrite it. y to the third over 2 times, flip the right side fraction, 8x squared over negative 10y. All right, again, with these exponents, I just multiply across and then simplify at the end. All right, so here I'll do it down here underneath. So multiplying across is going to give me 8. I like to do it in alphabetical order, so I'll put x first and then y to the third over 2 times negative 10 is negative 20 y. All right, so then I'm going to simplify. 8 and negative 20 I can divide by 4. Okay, so 8 divided by 4 is going to be 2. 20 divided by 4 is negative 5. Now this negative can stay on the bottom. You can move it to the side. You can move it to the top, the 2 if you wanted to. So that negative can go in any one of those 3 positions. X squared stays x squared. And then y to the third over y becomes y to the second, because you're going to subtract this 1 y that's on the bottom. All right. Excluded values. So excluded values are numbers in a fraction that would make the denominator 0. All right, and so we can't ever divide by 0. If you tried to put like 4 divided by 0 in the calculator, it comes out as an error. That just means it's undefined if we try to divide by 0. All right, and so again, that's called an excluded value. So excluded values need to be found before we try to cancel terms, before we simplify. All right, so to find an excluded value, what we're going to do is factor the denominator and set the factors equal to 0 and solve. Okay. Now, sometimes the denominators are already factored for you, but sometimes they're not. And so if they're not, you have to factor it first. All right, so let's go ahead and find the excluded values, or what makes the denominator an undefined value. All right, so on number 1, the denominator is already factored. It's x minus 2, x plus 3. So to find the excluded values, what we can do is set x minus 2 equal to 0 and solve it, and then set x plus 3 equal to 0 and solve it. And so from all the other problems that we've been doing with factoring and solving, you can see that it's just going to be the opposite signs of what's inside the binomials. So on x minus 2 equals 0, we can see that the excluded value would be positive 2. And then for x plus 3 equals 0, the excluded value would be negative 3. All right, again, the reason why is if you were to take, let's say, 2, and you plug it in for x right there, 2 minus 2 would be 0. Okay, so here, I'll just do it right here so you can see. I'll just plug 2 in for everything. Over 2 minus 2 times 2 plus 3. All right, so 2 plus 27 is 29. And then 2 minus 2 on the bottom is 0. And then 2 plus 3 is 5. Well, I can see that if I do 0 times 5 on the bottom, I get 0. Again, this is an undefined value because it gives me 0 in the denominator. And then the same thing would happen if I tried to plug in negative 3 for all the x's. I would get 0 in the denominator. All right? So 2 and negative 3 are called excluded values to the problem, or it's values that make the expression undefined. All right, number 2. So we have to look at the denominator. It's not factored, so we have to factor it. So here we can see there's a GCF we can pull out first, 4x. So dividing by 4x, we would be left with x plus 5. So now we can set 4x equal to 0 and x plus 5 equal to 0. And if we solve those, well, dividing by 4 is just going to give us 0. 0 divided by 4 is 0. And then setting x plus 5 equal to 0 and solving it, we would get negative 5. So this has two excluded values, 0 and negative 5. So the numerator has nothing to do with excluded values. It's only in the denominator. All right, number 3, x squared minus 9. So that's a difference of squares because we can square root them, and there's a minus sign in between. So that means it's going to factor into two binomials. X plus 3, x minus 3. Okay, again, if we set those equal to 0 and solve it, you're going to get negative 3 and positive 3. Okay, again, those are the excluded values. All right, so again, review on some terms from last semester. A monomial is a single term made up of numbers or variables or exponents. So for example, 5 is a monomial term, or 8x squared, 10xy cubed, those are all monomial terms. Binomial is two monomial terms with an addition or subtraction in between. All right, so 2x plus 5 is a binomial, x squared minus 4 is a binomial. So when we're simplifying expressions now with variables, there's a couple rules we have to be careful with. So if we have a monomial term on top and a monomial term on the bottom, then we can simplify those by simplifying the coefficients first and then dealing with the exponents of the variables. Okay, kind of like what we did in the previous on this lesson. All right, so here 3 over 12 can simplify to 1 over 4. And then x to the 5th over x squared would get us x to the 3rd on top by subtracting the exponents, right? But if we have binomials on top and binomials on the bottom, then only like binomials can cancel with another like binomial. So one on top, one on the bottom. If they're not exactly the same binomials, then you can't cancel them out. Okay, so again, binomials can only cancel with binomials. They have to be the same. So in this expression, it's already factored for you. So this is why factoring is so important, is we have to make sure that we factor everything. Okay, so on top we can see we have a binomial x plus 3, and there's another x plus 3 on the bottom, so we can cancel those out because they're the same. On top, though, we have an x minus 6 and an x plus 6 on the bottom, and they're not exactly the same because one has a negative, one has positive. Since they're not exactly the same, then you can't cancel those out or cancel any part of them out. So our final answer here would be x minus 6, x plus 6. Okay, so x minus 6 over x plus 6. I try to use parentheses, and that's just so you can see them as a binomial, and it keeps you from trying to cancel things out that you're not allowed to cancel. So like on this problem, I'm not allowed to just go ahead and cancel those x's out, okay, and then cancel the 6's, because you can't cancel part of a binomial. Binomials can only cancel with the exact same binomial. If they're not the same, then you can't cancel them out. Okay, so this is as far as you can go on this problem. All right, so let's go ahead and simplify each of these, and then we're going to also state the any excluded values. All right, so the first step is always try to factor. Factor the top, factor the bottom. That's always step one. Sometimes the problem's already going to be factored for you, and that's great, just saves you a step. But if it's not factored, then you have to factor it. Okay, so on number 4 here, we can see that everything's been factored. Nothing can factor any further. So we always want to get the excluded values stated first before we try to cancel things out. Okay, so excluded values have to be done from the original problem. All right, so all I have to do is look at the denominator, 4x and x plus 6. All right, so if I set 4x equal to 0 and solve it, and x plus 6 equal to 0 and solve it, these are going to be my excluded values. And so I can see that it's going to be 0 and negative 6. Okay, those are my excluded values. So now to simplify this, since it's already been factored for me, I can see that I have an x plus 6 binomial on top and bottom, so I can cancel those out. Now, the 10x to the 5th and 4x, those are monomial terms, and they don't have to be the same when they're monomial. I just can simplify them like I did earlier. So 10 over 4 I can simplify by dividing by 2. So that gives me 5 and 2. And then the x to the 5th over x, okay, again, that's all part of the monomial term. I can subtract exponents, and so that's going to be x to the 4th on top. So my final answer here is 5x to the 4th all over 2. All right, number 5. Looks like everything's been factored, and so we want to get our excluded values first. And so x plus 2 gives me an excluded value of negative 2, and for x minus 2, it would be positive 2. All right, so now we want to go ahead and simplify. Since everything's been factored, I can see I have a binomial x minus 2 on top and bottom, so I can cancel those out. And then that's as far as I can go. Now, when everything cancels off the top, what's left really is a 1. There's really a 1 on top left over. All right, so my final answer here is 1 over x plus 2. Again, I like to use the parentheses around the binomials. It helps, I think, for later on in more difficult problems. All right, number 6. Okay, so it doesn't look like they factored this one for us. So here we have to factor. All right, so we want to remember all our different methods of factoring. So on the top, it looks like a trinomial, and so we can use the x method. So 2's on top, negative 3's on the bottom. So we need two numbers that multiply to 2 but add to negative 3. Negative 2, negative 1. All right, so on the top, it factors into x minus 2, x minus 1. On the bottom, looks like there's a GCF we could pull out first. Okay, so I can pull a 2 out, and I'm left with x squared minus 1. Now, x squared minus 1 is a difference of squares because I can square root those, and there's a minus sign. So that can factor further. X plus 1, x minus 1. All right, so the full factorization in the denominator would be 2, and then x plus 1, x minus 1. All right, everything's factored now. So let's go ahead and get our excluded values. Again, we just look at the denominator. So there's a 2 there, but there's no x with it. So we can ignore the 2 because you can't just set 2 equal to 0. There's nothing to solve. All right, but x plus 1, we can set that equal to 0, and that would get us negative 1. And then for x minus 1, that would get us positive 1. Right, so those are our excluded values. And now let's go ahead and simplify. All right, so I have an x minus 1 on top and bottom, and I can cancel those out because they're the same. On top, I have an x minus 2 binomial, but there's no x minus 2 binomial on the bottom. And so that means I'm not going to be able to simplify any further than this. So my final answer would be x minus 2 over 2 times x plus 1. Now, we don't want to multiply that 2 that's in the bottom back into x plus 1. We don't want to distribute it. We want to leave our final answers factored all the way. And this just shows us that this can't be simplified any further. All right, so number 7, again, we're going to have to factor everything. And so it looks like we have a trinomial again. And so we'll use the x method on top. And it looks like we have a trinomial on the bottom. We're going to have to factor that also. So one thing, be careful with. This is why factoring is so important. And I keep telling you, factor as your first step. You can't just like start canceling the x's and the 7 and the x squared. Okay, you can't cancel those out because they're all part of trinomials. And trinomials, the only way you could cancel a trinomial is if you have another trinomial exactly the same on top and bottom, just like the binomials. Okay, so you can't cancel parts of trinomials out. It doesn't work that way. All right, so we want to go ahead and factor first. So we multiply 2 times 3, that's 6 on top, 7 on the bottom. So we need two numbers that multiply to 6, but add to 7. So that's 6 and 1. Now we are leading off with a 2 in front, so we're going to divide by 2 here, and then simplify the fraction. Okay, so the trinomial on top is going to factor into x plus 3, and then that 1/2 becomes 2x plus 1. All right, so now factoring the denominator, okay, again, we'll use the x method. So here 12's on top, 7's on the bottom. We need two numbers that multiply to 12 but add to 7. So that's 4 and 3. And we don't have to divide by anything. So that means the factors are x plus 4, x plus 3. All right, let's find our excluded values. Again, they come from the denominator. So that's going to be negative 4 for the x plus 4 and negative 3 for the x plus 3. Now we go ahead and simplify. I can see I have a binomial x plus 3 on top and bottom. I can cancel those out. And that looks like it. So my final answer, 2x plus 1 over x plus 4. Again, I like to use the parentheses around it. All right, and let's do this last question, number 8. Okay, we have a trinomial, so let's use our x method. 36 on top, 20 on the bottom. Looks like 18 times 2 is 36, and then adds to 20. We don't have to divide by anything. So x plus 18, x plus 2. All right, on the bottom, There's a GCF we can pull out, which is x, and then we're left with x squared minus 4. Now x squared minus 4 is a difference of squares, so that's going to factor further into two more binomials, x plus 2, x minus 2. All right, and now we'll go ahead and write the full factorization in the denominator. So we have that x that we pulled out, and then the x plus 2 and x minus 2. All right, let's give the excluded values. All right, so again, look at the bottom, the denominator. So we can set x equal to 0. That's going to get us 0. X plus 2 gives us negative 2 for the excluded value. And then negative x minus 2 gives us positive 2. All right, let's go ahead and simplify now. Let's see, we have an x plus 2 on top and bottom. We can cancel those out. And then that looks like it. So our final answer, x plus 18 over x parentheses x minus 2. All right. So again, at the bottom here it says, remember you can't cancel parts of binomials or parts of trinomials. And then make sure you factor everything as your first step. All right, and that's all we're going to do for this first part.